Okay, under unit shell, a command line interpreter that provide a traditional user interface. So that is under unit cell. Aduh, kenapa ni? My pen is not detecting. Okay. So under unit process, first of all, you need to know what is unit shell. So normally, as always remind to all of you that those questions for OS subject, we will ask you normally in the term of theory. So on theory, but for your final exam, we already decided that you're going to have the final exam for THE. I think we give you a question, and then you need to submit it like 5 hour letters, 6 hour letters. So how the structure is totally will be different with like your online test. Okay, so please make sure you carefully that this will be the first test that will be make different, because we want to avoid to ask you to make it compulsory for you to come back to UTM. That's why we need to have another solution, just to make sure that we did not push you to make it compulsory for you to come back to UTM just for final exam. Okay, for unit cell, a command line interpreter that provide a traditional user interface. So this statement normally in test, we will give you true and false. What is the meaning by unit shell? Which one is correct? Which one is or might be it is correct or wrong statement. So you need to remember. So under shell, what is the functions? Okay, shell will create a new process. Every time it's run a program, the command enter by user. So every time you enter a command by yourself, so a shell will create a new process. So what process normally that will be created by the cell is program execution. This is the things that are covered by shells. Variables and file substitutions, input output direction, pipeline hookup. So all of these you need to remember. Okay, under shell it will be 6 altogether. So we will directly pick from those this slide, and might be can be asked like what entities, or might be a program, or might be uh, which of the following uh, will be created, or maybe will be covered by shell. So you're going to give with several answer. 1 2 3 4 5 6 7. Mostly it's going to be similar. If it is 6, we give you 6 just to make you confused. Oh, I remember there will be a 6 there. So you will think, okay, if we give 6, you will tick all. So normally in those question, there might be a negative one, which is a wrong answer. Sometimes we also, just to make you confused, it is impossible to be all correct. So might be you said, okay, this one is incorrect, but normally sometimes it is correct. So it's depend. The things is, this is the questions that can be asked in your test. How are we going to ask you in the test, MCQ or part A and part B. Depend on which part that will become out. But the things just now I show you, it is part A. For part B, normally we will give you several answer. So total marks for part 1, normally one question will be equal to 1 marks. And for this one is for part A. For part B, it will normally one question will be like 2 or 3 marks, or might be it is 4 marks. So that is only different, but it is not a subjective question. And how about the example that you can write in the cell? Sometimes we call this as common CL, our common line over here. This is our common line. Okay, so shall create a process to run a command. This one is example of command that you write up in your terminal. So cat file 1, file 2. So if you know what is cat, then you know what is this process about. But shall we run this as a one process? Let's say you have another line after that. You have CP to copy, might be file 1, file 2. So might be you copy file 1 to file 2 might be. So this is another process. So this shell created this cat process, created copy process. So that is the meanings by this statement. Okay, shell creates a new process. Creates, you can see here, creates means that it's going to be created many process. Every time you run a program for the command that you enter at your shell here, at your terminal. Okay, it can be used for following purpose under Unix or also Linux. Display the text file on screen, copy the one that I shows you, CP, combine text file, add new file. So this is all process that can be made or created by your shell. So there is another example. This is in terms of ls. And you can see also here, there is another command that you ask if you are under COE subject. We call it as instruction, isn't it? Your instruction, mnemonic. So that is similar instruction. Like MOVADD, list is not there because you normally play around with arithmetic operation under your COS subject. But as example, because this one you already learned, as an example of this is type of instruction that you give in your program. So similar also when you write in your terminal here, shell will notice that there will be two things here, which is first is list, ls, and ws. I can't remember what is this. So you can see your shell will create two processes. Okay, two processes, and it will be concurrently. Alhamdulillah. Concurrently. And you can see here for this one, if you just ls whatever functions that you have, so it is just one ls there. But when you have this one, you created two things. Okay, it depends on how you write in just one single command line. Okay, your instruction to one line. Similar also in your COS subject. Might be you can have several operand in one single line instruction. This one in your shell. Okay, this is the three processes in Unix. Unix normally quite similar to Linux, okay? It is quite similar to Linux. Linux normally use unique like environments and architecture system. So you have a root. So I don't know about Fedora because I'm not playing around with Fedora, but if you want to use Ubuntu, to be as a root or administrator, admin, like in your computer, sometimes you have difficulty to open some program. So you need to right click and then run as administrator. So send to your things at your Linux and also Unix. Sometimes there is some program that you mentioned that will not be able if you are just a normal user. Because in our system also we have several user, isn't it? You can differentiate what type of user. So in Unix, if you want, in Ubuntu, if you want to be administrator, you're going to type sudo. Sudo at the beginning of your statement, sudo ls, sudo cp. So this just to mention that you are the administrator and you want to open some program as a administrator. So root is the beginning of all. Normally it is handle all from root. That's why you're going to see like root, or normally it is a home. And then username, SCR, what else? So it is starting from a root here. So our root will be categorized and divided into three, which is swapper, init, and page daemon. So then you need to know every single thing, okay? Because in the in your question, especially for your MCQ part A, we will ask you, okay, which one is the categories, the correct categories under root. So you need to know only this string. So each one of these after the init, then you have another category. User 1, user 2, user 3. Then after that you have like a desktop, USCR, what else? It's depend on your directory. You can check on your computer. Okay, but this is the most important three as the basic for your Unix. After that, it's depend on how you created your directory. Might be after your name as a user, you put a lot of new directory. Also, it's going to be many. Okay. Okay, about creating and terminating process. How you going to create? How you going to terminate? First of all, you need to know about forks. Forks is a system call to create a process. See? First of all, you need to know how to create, and then after this, how to terminate process. Last time you just learn on process, what type of process in your module 3. So this is also similar like a continuous from your previous module 3, but now you learn how to create it, especially in Unix. Again, I mentioned Unix also quite similar to Linux. So might be you can try to use this command to your Fedora. Might be it's going to be similar command. Okay, fork system a fork system call is to create a process. This is the first statement that you need to know. Might be we just give you like this example. Which one? Okay, I give you like forks. Okay, I give you forks. Is a system call that ataupun I put is create a child process. You can see here in this statement is just create a process. But I can play around. Fork system call is to create a child process. So you need to know child process is this one. If I give you that statement, you need to know that it is a false. So just that type of question can be asked easily in your test. Okay, so again, all of this module will be covered in your test 1. Okay, that is under creating a process. Second, to create a child process, where a child process is a copy of a parent process. So this the command that you're going to use is PID equal to FORK, and then you have to factorize there. And call without any argument is your FORK. Fox will return a integer value to variable for your PID. So parent process, which is Fox, normally a process ID for a child process. This one is normal things, common things that you need to know, because you know that every single thing in this world having a parents. Then after that, you're going to have a child. So normally, child will be a process below a parents, and it is a process ID for a child process for your parents. And child process is 0. So this one is as just in terms of the variables or integer value that will return by your P. If you want to check whether it is a child process or a parent process, you will know that parents process will return you with a positive value, while for the child process will return with the value of 0. This one is quite easy because it's easy for you to remember only these two different things that you need to know, right? Parents and child. Parents, any positive value, child will be returned with the 0. And another one more things is in term of terminating. If you want to close, if you want to shut down your process, you just using the simple command as exit. This system call is to terminate, to shut down, to exit, to close a process. So it's quite simple, right? Because it's a common like text normally you will use in terms of to terminate. So you have learned forks for a parents or creating a process. PID forks will be create a child process, and parents will be returned for PID value will be a positive value, and you get a return of 0 for a child process. Another one more things you learn that exit will be a system call to terminate or shut down a process. Okay, applications of forks. So remember that this one is to create a process. Now we learn what applications of forks that will be available and what type of process, something like that, because you know Fox is a process, creating a process. So to make duplicate of process, if you want to duplicate, we mean like we copy the process, existing process, so that a copy will be do one task while another will do another task. Okay, let's set example. Okay, this is the things that I normally do. If let's say I want to edit something, for my Microsoft Word. Okay, I have the like journal. I write the journal, so I will write journal, 20 April. Okay, I name my journal. Okay, 20 April. Then, when I want to edit, I'm not going to edit inside this, because if I directly edit, I don't know later on what is the previous version. So I will copy it first, isn't it? I will copy it first, and I will make that copy to be 21st April. So I know if I check here, might be I was like, why this statement, I write previously? So this one I can refer back. So in the process, if let's say you have one program, you write a word that the word is for you to edit there's those journal to be 20 April. But another one might be you want to send this similar journal, but you want to send to another different person, so it will be like 20 April. So just a different name. You're going to see that this one will be different with this. Similar also in terms of process. This will be run a different process. This will be different process. That's why you're going to make a duplicate and you're going to copy it. Another one will do another task. Another one will do another task. So that is the purpose for you to duplicate a process. And if you want to execute another program, because you have already, okay, you have already like to process, because you already copy and duplicate it in terms of the process that you already created by your Fox. But how you going to execute those copy things for your process or a program that you want to run? So you're going to use a execute, EXEC, execute system call after your Fox. Fox, whatever functions that you're going to do, like duplicate just now is CP, right? And then after this one, you're going to execute after your command for Fox. Okay, just now you have also copy. No, okay, you can also like write copy after you are creating your Fox, and then after that you need to remember you're going to have the execute, just to execute another program. Okay, here is the example. Before that, what we're going to happen, and after that. Okay, first of all, before your Fox here, you have like, might be you want to print something. Okay, you want to print something, this is another one program also, right? Because you give instruction, please print this one. So this is one of the process. And then remember this one, this is a child process. So pit equal to for factorize here. And then you have another one is print to. So this is another process. So what will handle, this will be handled by your PC. So what is the program, the output of the program? So you're going to have one, this is one, and you're going to have two. But you can see you're going to create another process, which is you duplicate it. duplicate it. That's why you're going to have another one more things, which is 2. Although you are not mentions that you did 2 process, you're not going to say that you're going to copy and etc. But you see there will be another fox, which is under this one there will be creating another child. So this child will print the next one, which is copy these things. There will be 2. Sorry. So if let's say you have after fork, so might be you can try to copy this and do it in your Ubuntu, see whether you get the similar output or not. After fork here, what is happen after you are having your forks? So when you are having your forks, okay, this one is the flow. Actually, if you point to here, and then after that is point to here, and this is the similar things after your forks. Okay, this is the flow and this is the output. Pointing up here and then it's pointing up here. After that, it's going to copy again and to do this one. So another example, this is the thing that I mentioned that I think it's going to be also important for your test 1. If let's say it's mentioned here, you have 2 PID. You have 2 children here, PID1, PID2, PID1, PID2, and you are creating it, and you're going to print your PID1 and PID2. This is the things that instruction that you're going to give to your shell. So total number of process created is 4. It's already mentioned. So how this process will be creating 4? So 2 for the pit 1 or 2 for the pit 2. Let's see the example here. So first of all, you're going to read one by one, similar also like what happened in your COA. First, you're going to read PID1 equal to false. And then at first time, of course, your output doesn't show anything because you don't know what is the things under PID1 and PID2. And because you have already mentions that you have created 4 processes, that's why it will be counting until 4 times later on. Okay, so first of all, you have assuming that for PID1, after you point here, you're going to have the value for PID1 first. And your PID1 equal to 5 here. If the PID1 equal to 5, you're going to have the ID equal to 5. And you're going to point out later on to your PID2. You're going to see that after you execute the single line, it will return back to a 0, as mentioned in your previous slide here. Okay, next after that, you're going to have another one, which is third line. Okay, after one by one, step over for your subject, or similar also in your single line in your Unix. So you need to print the PID1 and PID2. It will be continuous back because you have 4 processes. For example, here you have first ID equal to 4, and then after that 5 and 6. Okay, first the value PID we put here. Let's say example, you are having the output of 5, and you know that this is from the value of your parents. After you execute this line, then you're going to get the output return to 0. It will be written back to another last line here, which is you're going to copy the value of 5 just now from this to here, and you have the value of your PID. Where is my pen? Okay, you're going to have the PID2 later on. After this, you're going to have the PID2 equal to 0. So after that, you're going to see you have another one more, which is 4, because you have 4 processes. Assuming that your ID now equal to 7, and where the 7 will be putting at your previous again. You can see the flow. First of all, you're going to have the PID equal to 5 at the beginning. Normally in question, so supposedly it will be mentioned, okay? And then you have the ID equal to 5 here. This one will be written back to 0. When you already finish this line, it will be pointing up here. This value will remain as 0, but for third process here, it's going to follow back the previous ID. Okay, for previous ID, it will be taken to your PID1. This is your ID of your parents. And for this part, after that, your PID2 will be 0, right? When you have a process 4 here, you will return back to 0, but your previous, you check your previous, and you check your previous, it will be follow the ID that you have. 5, 6. And then you have another one, your for PID2, it will be following the next process. So later on, might be I will give you example I try to run in my Fedora, and I will show you how it's going to be looked into one by one, especially for the output. And I will also try to find one questions that having all the instruction. Might be you can try to do the exercise, which is quite similar to your test 1. So after you have your forks, just now you already have your forks. You create your PID, which is child process, and how you're going to terminate your process. If you just left it, it's not going to terminate by itself. You need to execute it and terminate it. So the application to execute a new process, this is the command. You already learned it previously in previous slide. So process ID for new process equal to process ID for program that call the execute system call. If your execute exec is executed successfully, control will never return to the program that called it. So you're going to directly close. So it's not going to return back. So there is also several system call under your execution. So if let's say you can see here, you have several char value for what, arg, what else, integer return. So this one, you want to return and you're going to execute it following all the values that you have. So what is path that are available in our example here? It is a name of a file that consists of your program that you want to terminate. While for the arg0 and arg1 and so on equal to n, it is a program name. And after that, you can see here, this is all the parameter that available. So also similar, sorry, this one is executes means that you want to run, sorry, if you want to run it, so you're going to call all of this. If you want to execute, you're going to do exit. So if you want to terminate a process, if you want to terminate the process, you're going to use execute. So normally there is two value, which is 0 and non-zero. If your status is 0, you put 0, it is a normal termination. If there is a value for your status, it will be called as abnormal. So if we want to ask you in MCQ question for part A, we can ask you directly like, exit 3. What is this a normal or abnormal termination? Just simple as that. So it can be like 1 marks for MCQ. Okay, how you're going to use your fork creating a process, how you're going to execute your process in one single program here. You can like see, first of all, you're going to declare your PID. After you declare your PID, but here you can see you're going to declare it as integer. I don't know whether you are familiar with all of these command. I don't know whether you already tag like others programming language. I think under our COA subject is not deeper on all of these program, right? So hope that you will understand also. Maybe you can also like copy paste and try to run. And this one we want to create our forks, creating a process, child process. And here you can see there will be a looping, but this will give like a scenario. If your PID value is more than 0, then you're going to do this step. After that, if you finish, then you're going to exit. This one is what? If it's a 0, it is a normal termination. Means that you're going to terminate it. So first, what we will do in this statement, you're going to wait for the integer and you're going to print. This one is not a list, a common list, but you're going to print because this is the things that you're going to print all. Okay. After that, you're going to execute. Going to terminate all the process that you created. Then if let's say the value is equal to 0, if the value of PID is equal to 0, you're going to execute, means that you run the process that you created. And this is the things that listed similar to these instructions. What is the pass, argument, and so on. Saya dah pergi mana ni? Okay, after that you can see if let's say you're going to print error, if your statement or your process is failed, you're going to process error. If the value not in these two things, it is not more than 0, it is not 0, then you're going to print error with this statement, false, fails. After that, what will happen? Because of this, you're going to execute, and it is not normal, which is abnormal, because you're going to have the error. So that is the things normally that a simple program like this will be do, and where you're going to apply your forks and also execute. Just a example. So that is the only things that cover in your module 3 under Unix. It is just a few slides in terms of process creation and termination. So it is not too much. You have only a few command, but I think this example will be coming up also. And another one is the things on your command, faults, pitfalls. Might be it can also ask in your part A. Okay, so after this, we're going to continue with our module 5. But before that, might be we're going to take a 5 minutes break. Is it okay? Okay, we take a break first, okay?
Okay, Ate.
Okay. Okay, everyone. Let's start our continue our class again. Please enable your webcam. We're going to continue with our module 5. Are you still awake? Okay, I think I just continue with our module 5. Okay, as mentioned, our module 5, it is not all on theory. There will be some things related to your mathematicals. There is also equation later on. So first of all, might be a few slides earlier. It will be more on theory, but after that, you're going to learn on calculations. Okay, in this module 5, we're going to learn on process scheduling. So there will be several under basic concept. This basic concept, of course, is all theory, but is scheduling and etc. as normal. And then after that, you have a scheduling criteria and algorithm, but we cannot finish all. Might be we just until half, but today we're going to touch until a calculation also. So this is the objective why we need to learn on in scheduling, for you to learn on CPU scheduling, and which is basic multi-program operating system, and discuss various CPU scheduling algorithm. So there will be several things that you need to know about the basic first. Basic concept. You only have two bursts in your CPU and also input output burst cycle on your scheduling. Okay, in your scheduling later on you're going to have a process. Okay, especially in our 5-state model. But in that, before you go deeper, you need to know in terms of the CPU and also input output bus. So it will be followed by input output burst for CPU. So first of all, mostly you're going to have the CPU burst first, and then followed by input output burst. So it will be maximum CPU utilization obtained with multi-program. Normally now we are using our multi-programming. And this is all the behavior if we have the processes that exhibits. So here we will be following the process. Okay, CPU distribute. Okay, this one is you can read. You can see here the example. Okay, this one is an example. You have the CPU burst. This is handled by CPU. When you want to load, when you want to add, you want to store into your memory, all will be handled by CPU. And okay, example, let's say you want to have EAX equal to EAX, and then you're going to take from EBX move. So you're going to add this value into your EAX. So all of these will be handled by CPU. An example for input output burst is something that in your program you ask your user to key in the value using your keypad. Maybe you're waiting for some integer invoked or triggered by your user in your program. That's why you are having something which is called wait for input output. Input output, you know already, right? Whether it is a keyboard, a scanner, all of that, it will be an input and also output. And if let's say after that you already might be you have pressed 9 to your keyboard, then this input output burst will be finished because you already press something. So you're going to store might be the value to your CPU, so CPU will handle back. So it will be continued depending on your program. So here is an example when you are having the input output and also CPU. Okay, if you look into this program, it asks you to print input output first, enter first integer. So if you print, is related to what? Your output, isn't it? So your output, it will be in terms of output, input output burst. Similar also here, scanf. What is this mean? It means that it's wait for you to key in or press a value of this D. You want to press, you need to press this value, so you're going to wait for user to press. So it will be input output burst related to your output, related to your input. For this operation, if it's related to operation, normally our CPU will be handled because there is no output devices or input devices will be calculating, because your calculations or whatever equals to your equation will be handled by your CPU. And again, you can see here print F means that you're going to have the output. What is this? This is the input output cycle. Okay, so that is the things, just a theory for you before you go to the scheduling. Okay, I hope that you still remember our 5-step model, because 5-step model is important in your test 1. I think there is several 1 or 2 questions will be asked from your 5-step model. So please make sure you remember also in terms of inside diagram, what is this and etc. Okay, example here, this one, chapter 5 is not covered, but this is what of a question can be asked. It is not only 5-step model, another one is 2-step model. Maybe if you have a graph, a diagram, we can just delete this. We delete this, maybe we delete this and we put the labels. So normally in this type of question, we will ask in your part B. How the question will be look like is, which of the following is correct? I don't know, whatever it is for your test 1, correct statement or maybe correct entity, maybe correct components for the picture or graph, or might be 5-step model, I don't know. So you're going to correct for the following label. Okay, so we are going to give you a label. So in the answer part, you will be given with A, and you have the drop down. B, C, D, you have the drop down. So normally in this drop down button, there will be, if it is 4 answer, we will give you something like 9 and more than that. So you're going to pick which one is the correct for the ABC. Okay, for part B, in your test 1. So maybe you can try to look into diagram. What is diagram spot equation for your test 1, okay? So example is already showing like this. It can come out for your test 1. Okay, job and process status. This is your 5-step model. You need to remember, okay? You need to remember you have the new state, ready state, running state, waiting state, terminate. It can be also asked in your test 1. If you have these 5, maybe we can say, okay, which one is a correct state for your 5-step model? So might be one of it we just pick out from 2-step model. So if you can't remember and you mess up between 2-step model and 5-step model in terms of the things, so you will pick the correct answer. Okay, that is very important for your test 1. So job move through a system. There will be 2 type of job only. First is long term and second in short term. For short term, it will be CPU scheduler, and for the long term, it's going to be for your job scheduler. I'm not going to teach on the 5-step model, but you can see in between actually there will be something which is in terms of the process. Before you can go to directly to the ready state, although you last time you learned that there will be some a trigger and so on, right? But normally those movement will be handled by job scheduler. And if you want to invoke also or terminate, or maybe you already successful run your running state, it's also similar. Job scheduler. The only thing that will be handled by your CPU scheduler is inside of this. This will be handled by your CPU scheduler. This process, this process, this process, all will be handled by CPU scheduler. While 2 things that will be handled, which is from new state to ready state, job scheduler, from running state to terminate, will be handled by job scheduler also. So it can be asked also, might be in your test too, what is process that will be handled or controlled by CPU scheduler. So you need to know interrupt issues, input output requests, patch faults, signals to process, and continue process, as will be handled by your CPU scheduler. Okay, this is the things can be asked. That's why you need to remember, okay, this one will be controlled by job scheduler. Here is what terminate. I can't remember. This one input output and signal process for your B. So that's why you need to remember a 5-step model also might be your 2-step model. And if you have a diagram in your previous module 1, 2, 3, please also remember, because we just play around with that value, that things we delete and we label it. Okay, let's see here in terms of the job. Users submit job, which is we also call it as a batch or interactive. There will be several there will be several job or batch or interactive, which is first accept, and then after that you have a state changes. Accept means that you put a hold and place in the queue. And the rest is changing the state when you want to change from new to ready, from ready to running, from running to waiting, and also changing to terminate. So this is all a 1 process 2, 3, 4. This is also under job state changing. But in terms of the accepted, it's going to the task is to put on hold and place it in a queue, because you need to also check whether you have existing program that will be running. That's why you need to hold first, and then if everything okay, then you're going to directly go for job state changes. So this is all on theory. You can try to read it. And under our PCB and queuing, because you can see you need to also having a queue and hold there, so it will be a job CPU will be handled. So what is the task for this job PCB, which is going to create a job scheduler to accept the job. Okay, and it will update the job execute, and queuing will be used PCB to track a job. Might be it's going to check what is existing process that happen in background as a queuing, and it is will be contain all necessary job managing processing data. That's why a PCB will be linked all the form queuing, which is the things that job not linking from the queuing. So it is also manage the queue by using two technique, which is process scheduling policies and process algorithm. But we're not going to cover it directly. I think later on you're going to go deeper. This is also under scheduling, but it is important, okay, scheduling things, because after this you need to learn on how you need to draw your process state. So this one is very important, scheduling onward, because this one is related to the process state. Previously all a theory, just a basic theory you need to remember, but after this onward, it is also related to technical on your understanding. So under scheduling, the selection of process will be carried out by a CPU scheduler. So it's going to have a running state, waiting, ready, waiting. This one is running to ready, waiting to ready. The four thing here. Where is it? Okay, this is the four thing here that handled by CPU. This one is handled by your PVC and queuing. But for these four things, job here will be handled under scheduling. And who is handling his is a CPU scheduling. And there will be a non-preemptive and also preemptive scheduling. So if you can see here, all of these 1, 2, 3, 4 will be handled by non-preemptive, while for preemptive only 2 and 3. Yes, 2 and 3 under preemptive scheduling. So this is the very big differentiation between preemptive and non-preemptive scheduling. The rest you can try to read. This is just a theory. The most important here, okay? The most important here is every single thing when you try to run running a state to waiting state, running a state to ready state, and etc., and also process a termination, all of this will be also correlation to dispatcher. Every single process, you can see dispatcher modules give control of CPU to process selected by CPU scheduler. So what is content here? Switching context, switching user mode, jumping property location, which is from user to restart, and etc. So you're going to hash the dispatcher before. Okay, let's say you have a program and you're going to create a process, right? Process A, you have another process B. when you want to jump from process A to process B, before you can jump, you need to have dispatcher. Okay, before you're going to have process B, you're going to have dispatcher. And the dispatcher here, the duration will be called as dispatcher latency, which is time to take for this dispatcher to stop the process A and start a process B. That is the definition. Okay, in terms of picture, you can see here, if you have a process 0, you want to execute and then you want to terminate the process 0 because you want to have another process. So while you terminate this, who going to do? Dispenser. Dispenser will be taking the place. So dispenser will save the state of your previous one, and then it's going to restore and continues with your process 1. And this duration will be called as dispenser latency. So let's take a look. Okay, this one, this definition, differentiation between these two, you can look into. Let's take example. Example here is give you 3 process. You have 3 process, process A, process B, process C. Okay, first step, if you're given with the example like this, you have also dispenser. Remember your stack in your CPU, COA subject, you have the addresses or offset. Okay, here the dispenser starting from 000, but it is not stated until where. Normally in question it will be mentioned, okay, from 100 to where, from 5,000 to where, and from 8,000 to 12,000 is process B, 12,000 to process C until where. So all these addresses will be informed in your test. But here just example, we just assume it to be like this. Okay, dispenser we assume from starting 100 to 105. If you have like this, the addresses, it already given you, so you need to know that the maximum cycle that you can have for dispensers is only 1, 2, 3, 4, 5, 6. 6 cycles only for the dispenser because only 6 addresses that cover. Okay, this is for trace A. Normally, as mentioned, okay, in exam, in test, it will give you the starting value and end value. Similar also process B and process C. But in example here, it's just give you the starting value. Normally, it's going to give you the ending. After this, we will also have the exercise. Example, it gives you a full information. We will do together also. Okay, this is step by step. You need to have this value and you're going to do the second step. After that, you will draw like this. Okay, because we have process A, process B, process C. Normally, we will follow the sequence. We will follow the sequence. After we already, first of all, we're going to execute A, and then we're going to terminate it, and we will do and run our process B. But before we go to the B, we're going to have a dispenser process. After B, we're going to go and we're going to terminate B, and we will run a process C. But before we run a process C, we will have the process dispenser again. It will continue after C. Supposedly is going to continue back with A, but we're going to have dispenser. After A, we will go to the B, dispenser, C, etc. But in between, suddenly sometime your addresses, your process of terminations, you are having a block process. That's why sometimes from C you direct jump to B. So we will see the following sequence after this, okay? So first of all, you need to know the process A to B, B to C. That's why you can see here, first of all, 5,000. This is process what? Process A. Process A here. You have A. And then, what will be happen? From process A, you're going to go to process B. Can see? Process B. Process B. But, as mentioned before, process B, what you're going to have? Your dispenser. After your B here, after your B, okay? After your B, you're going to have C. You can see? You have a C. You already done your C here. And then after C is going to go back to what? A. It's going to go back to A. You can see supposedly, okay, you are already until here, okay? You are already until 5005. Later on, I will inform you what happened here, okay? You are until 5005. And then supposedly it's called your 5006. But you can see until after your C here, it will be, okay, it will be go to the process of A 5006 continuous address. Okay, you need to know that it's continuous address. It's not starting back at 5000. It continues to 5006, which is process A. After C, process A. But before that, you're going to have what? Dispenser. After A, it will go to the process B. What happened here? You need to check your process B. It address only at 1000 until at 1003. That's why the address is already finished. Because it finished, it cannot go to the B because already finished, isn't it? So that's why it will jump back to the continuous of our C here, 005. It's starting at 006. Okay, this is the flow that you need to remember. Later on, we look into another example. Okay, in between, you are having dispenser. In between, you are having the dispenser. Address of dispenser will be continuous. That's the only difference between process and dispenser. This is dispenser, this is dispenser. Continuous address. You can see here. But the maximum for a dispenser here is 6. And normally in question, it will be given the CPU bus maximum. So in question, it gives you here, if in this scenario, it is 6 on the maximum. That's why you can see here, process A until 1, 2, 3, 4, 5, 6. 6 cycle only. For dispenser, it depends on the maximum also and also the addresses. Our CPU are having 6 and dispenser having 6, then okay. So this is your dispenser before you go to the process B. And process B will be start at 8000. 8000. Supposedly it is a 6 cycle. Why is until only 1, 2, 3, 4? Because the address here that given only 4. You cannot have 8004. Okay, that's why I mentioned in question, your test 2 later on, it will give you the full overview. After B, you're going to go to C. But before that, you have the dispenser. This is your dispenser. For C here, it start from 12000 until 6 times. 1, 2, 3, 4, 5, 6. And then it will go to the A again. Continues from previous. And what you're going to do, you need to draw the process step. Remember your digital logic subject, you are having the timing diagram, you are having the step diagram. Now in your OS subject, you have process step. You need to draw. Okay, you need to draw the state, process state. In terms of the things here, you can see you are having a process A, process B, process C, process and also dispatcher. Okay, this is example only. You can change it depend on how you draw. But for example here, it's already give. You can see here we start just now with our process A. Process A will start at 0 here. Okay, it will start at 0. Now it is a 5000. The addresses, okay, the addresses for A. And it will continue 6 cycles because CPU maximum is 6 cycles until 50005. And it will be stopped. It will pass to process B. But before that, it will be doing under your, you can see 6 cycle, your dispenser. Dispenser is 6 cycle. You have 100 until 1005. After your dispenser, you're going to start your process B. It will be start at 000 until you're at 004, I think. I can't remember this. But it is not full 6 cycle. It depends on addresses that are available in your process B. I think 4 cycle only. Then, you can see it blocked. Why it blocked here? Because you don't have any address anymore. You cannot run it. So everything will be blocked. That's why after C it will go to the A. After A it go to the B. It go to the C because there is no B anymore. Okay. So B until here and then it die. After B, supposedly it's going to go to the C, but first you're going to call the dispenser again, and you can see there is 6 cycle. Dispenser start 100 to 105. Kenapa banyak ni? And after dispenser is called the C. C start with 2000 until 2005. It is similar to this, okay? But your question will be not asking you to draw this one, but it will ask you to draw the process step. After here, all of this you need to know, yeah? Okay, 6 cycle, this one is 6 cycle, this one is 4 cycle, this one is 6 cycle, 6 cycle, 6 cycle, etc. Okay, over here, after your process C, you're going to go to B, but your B is already blocked. Where you're going to go? You're going to go to the A. Before you go to the A, you need to go to dispenser first. 100, 105. And after it finish its cycle, it's go to the A. Now our A is starting with 5006 until 50012. Until 50011. 6 times. 6 cycle. And after A, supposedly is go to the B, right? But B is blocked already. What happened is go to the C. Before you go to the C, you need to go to the dispenser again and go to the C until finish. That is the things it is must to be asked in your test 2 to draw a process state. Okay, let's take a look in terms of very complete example. Complete example. I think only until here, then we will stop. Okay, let's see the example here. You were given with the three process again. You have process A, process B, process C, and you are lucky that all the process already give the addresses. This one will be asked, okay? So please make sure you understand. Process A, process B, process C. You know the address already. Then you have the information. Process A will request input-output source at instruction cycle 4. Means that at in your instruction just now, okay, you have this cycle, right? This is your cycle. At this cycle 4, your process A will call the input output sources instruction. Means that it will stop the process and waiting because it called the input output. It will be waiting for the input output, so it stop until 4 here. I dah pergi ke jawapan ke? Sorry. Okay, so here it will be stop until here. Okay, and then what else did ask you inform you? Waiting, dia akan wait for the input output until up 30 instruction cycle. 30 times, okay? Means that at the beginning at cycle 4. Cycle, okay? This cycle 4 until 30 cycle. 1, 2, 3, 4 until 30 cycle, which is 34. Because 30 cycle is going to wait. If this one, when it wait for the output, input output, you're going to do block. So you cannot call this process A anymore because it's just now waiting. So waiting is going to block. Okay, so that is on this statement. So please make sure if the test to ask you about this instruction, you know, okay, when cycle 4 until 30 cycle, you're going to wait, so it will be blocked. You cannot call this process A. So process B and process C will be ping-pong together, calling each other. After that, you can see process B request input output at cycle 35. Oh, now at cycle 35, the turn for B calling for the input output. Means that it's going to waiting. And waiting, how long is wait? 20 cycle. So what will happen? It's going to be blocked. Okay, this is the addresses. And there is also another information here. Okay, you need to draw until 70 cycle. That is the things that you must to do. And there will be CPU burst process is 6 cycle. So it's already mentioned. If you run process A, it's supposed to be 6. B, the maximum will be 6. C will be 6. Dispenser also will be 6. But you need to also check the addresses that are available. If it is less, it's okay. If it is more than that, you need to stop until 6 only. So let's take a look. I copy this to the example beside, so then we can see what is the scenario and how to draw. Ya Allah. 12. Okay, I put here and another instruction. Okay, another instruction I put here. And this is the addresses that you need to follow. Okay, first of all, we already read everything in our question. So we will have 3 process. You can also write this dispenser and you draw similar like this, and you follow. When you running, you put black later on. Okay, we go one by one. First of all, as already teach, you're going to start process what? A. Process A, supposedly you're going to draw until 6 because of what? Maximum CPU burst is 6 cycle. Okay, you draw 6. Okay, you draw 6. But I read this statement at cycle 4 means that until here dot. See, you going to apply dot similar to your digital subject. Until 4, you're going to stop because you're going to wait for your for your input output. Okay, so that's why you cannot do until 6. The maximum you cannot do because after 4 cycle, it will be called for a input output. So here is block. Why it block? Again, as mentioned, it waiting for the input output. It will wait, okay, user to press any key, so it will be blocked. Others, process A, process B or C, to call it back. Okay, it will be blocked. How long it will be blocked? It will be waiting until 30 cycle. So you will know, and from 4 here, 1, 2, 3, 4, 5, 6, 7, until 30 cycle, it will be until 34. So here, we need to draw the block until here. Okay, so that is the first thing. After A, where you going to go? You're going to go to the B. But before B, you need to have the dispenser. That's why after A here is go to dispenser first. Starting here is, okay, I put the address first, so then you know 0000003. For our dispenser, it start at 2000 until 2004. You have how many? 5 cycle. 1, 2, 3, 4, 5, 6. Here is 5, 6. 5, 6. 6 cycle. Why you have this here is only 5 cycle? 1, 2, 3, 4, 5, 6. You can see here it mentions that you are having 6 instruction, but I think it's supposedly 5. Let me check carefully. 1, 2, 3. Kenapa I kira ni sekali? 1, 2, 3, 4, 5. Sorry. Okay. So only 5 cycle. Why is 5 cycle although it's mentioned 6 cycle as the maximum? Because you only have the maximum address 5 only. That's why you can only until up 204. You cannot have 205 because this is the only address that given to your dispenser. Okay? After you draw here, you're going to go to the B. So you start your B at 2000 and here will be 2005 because it is a 6 cycle. We have here the condition for B, but it is start at the 35. So this is not apply here. So I just ignore first. Okay. Now, after B finish, I'm going to go to C. Before that, I need to go to the dispenser. That's why I go to the dispenser after this cycle. After this cycle, I go to dispenser. Again, it start with 2000 until 2004. 5 cycle altogether. Please make sure you remember dispenser only can repeat their addresses. For the process, you're going to continue, okay? After finish dispenser, you go to the C. So here C will start. C will start with 2000 until 2005. After C, supposedly you're going to go to A. Before you go to the A, you're going to go to this dispenser. Let me do. Here I go to the dispenser. It start at 2000 and then 2004. After dispenser, I will go to the A. Okay, I go to the A. Ting ting, cannot. I cannot call A. Why? Because its block is still waiting. So that's why I cannot go to the A. I turn out to be B. So here, go to the A. I don't want to go to the A because it's blocked. I go to the B. So I will go to the B here. And I will start a 6 process cycle. It will start with the 7006 here until 7004. Okay, but you can see here at the 35, cycle 35, until here. We start just now at cycle 31. We start at cycle 31 until cycle 34. 35, sorry, until 35 here. I will wait, means that it will be blocked. Okay, it will be blocked. That's why I will do only until 31. 31 is 1, 32, 33, 34, 35. So until 35 only I will do. So how many cycle? 1 to 2, 1, 2 to 3, 1, 3 to 4, 1, and another one, 4 to 5. 4 cycle altogether. 4 only means that 7005, 7007, 7008, 9, and 10. 6, 7, 8, 9. 9, sorry. Until 7009. So I stop here. Sorry, it's going to be quite ugly, okay? So 779 is stop. So from B, I will go to the C. This is the following sequence A, B, C, A, B, C, A, B, C, okay? So B, I'm going to go to C. But before that, I will call what? I will call D first. So from here, I will go to the dispenser, start 2000, 2004, 5 cycle altogether. Until here, I will go to the C. There is no condition at all for C. That's why C, there is no waiting. There is no waiting, there is no blocking. Only block at the 2 condition A and B. This first block and another block. Okay, now I will start with 2006 until 2006, 7, 8, 9, 10, 11. 2011. Okay, until 2011 only. And then after that, I go to the dispenser and go to the A. A now, it start with 5004. Until 4, 5, 6, 7, 8, 9. 4, 9. Here. And it will go to the B process. After A, it will go to the B. Wait, supposedly until here is go to the dispenser. And this function will start at 0, 0, 0, 0, 0, 0 until 0, 0, 4. For here, it's going to continue with blocking until where it will be blocked. Starting at 3, 5. Supposedly, it will be wait until 20 cycle from A to the B. 20 until 55. We start at 35. We will stop until 55. Here will be the blocking finish. So from here, supposedly A will be continuous to the B. But just now it's blocking. Supposedly it's supposed here. Why is answer at the C? Is there any instruction here? The address is still have a few. This one I will double check, okay? But you can see here, the point is, if here after that you're going to go to the C, if you go to the C here, this one I will check supposedly from A is going to go to the B. C, A, B, B, C. Okay, but you can see here, after that, it only have 4 cycle. Why? Because you have starting from 2012 until 2012, 13, 14. Do 2017. But you can see the address. The addresses is only until 2015 for your C process. That's why you only until 2015 you're going to stop, which is 4 cycle. So after that, there is no addresses anymore. So it will be totally terminate. Close it for your process C. Then you will continue only with A and B, A and B. Okay, any question for this part? So you can see here in the process, it show you like yellow color here, but you can also draw like this. Okay, this is also similar. This one is just showing you like maybe a yellow color, but this one is similar to the example just now. I will double check back why from A to C. Yesterday class I also didn't realize this because I focus on the addresses. The rest, I think all information is okay. I hope that you understand because this one is very important. You're going to apply later on in your next for calculation and etc. Any question related to this example? So please make sure this one is important for the for the process that you need to draw. Mana dia punya statement to draw? Following instruction, blah, blah, blah. Complete. Okay. Drawing the process step. So you need to draw. Might be this one also can be asked in your final exam. Who knows? Because we don't know yet how we're going to ask in your THE final exam. So something that related to take off exam. So it's going to be tricky drawing, calculation. So that will be a question that will be asked in your final exam. So if you have no question, we will stop our class and we will continue again.